This video, we're going to go over the difference between primary and secondary standard solutions. So there's going to be a term here that we've got standard solution. A standard solution is a solution of very certain concentration. So we really know what its concentration with high certainty. So we want this to be a solution that has been made so that we know exactly what its concentration should be. And so the process to make a standard solution is to know what the amount of certainty we've got is, and to make sure that all of the solute that we are expecting to be in the solution is in the solution, and that we have added the correct amount of solvent. And so there's a very specific process to that. Now, a primary standard solution is the most accurate way for us to measure or for us to make a solution, and it's going to be made from solid solute. The solid solute is something that we can do as a mass. So we're going to calculate its mass and measure that mass as accurately as possible. When I am measuring the mass, I'm going to measure the mass in a beaker on the scale, and I'm going to zero the scale when I have the beaker on it. Then I'm going to put the solute in until it gets to the measured amount of mass that I want. So that way I'm measuring exactly the mass of what's going into, in the case in our class, we'll have 2 decimal places. And so that last decimal place is going to be how we're going to be able to decide how many sig digs we're going to have, right? Like, so if I had 10.00 grams, that's 4 significant digits. The accuracy of that is helped by knowing that all of the solute is in the beaker that I am going to start adding solution to, so that I don't have any that's being transferred from a weigh boat or something like that. Now, sometimes we need to use a weigh boat, but then we're going to need to clean that weigh boat off to put it into the beaker. That will not happen in our class, but it will happen occasionally in a science lab, I guess. So once we've got the mass in the beaker, we'll take the beaker off, and then I'm going to add half the volume of the solution. So if I'm making 100 milliliters of solution, I add 50 milliliters of solution, and I stir to mix it. So I want to dissolve all of that solute so that this solution has all of the solute in it. Then I will transfer that into a volumetric flask. Now, a volumetric flask is a very precise volume. So they're only used to measure one volume. Ours in class are 100.00 milliliters. So I get 5 sig digs of accuracy for the volume. So I take that solution that we've made, transfer it in, and then what I'm going to do is I'm going to rinse out the beaker and transfer that into here as well, so that all of the solute goes in. Now, frequently, you're going to use a funnel to transfer it in, so then I'm going to rinse the funnel with water. That's the reason I only use half this amount of water, because I have to keep rinsing to make sure all of the solute gets into the volumetric flask. Once I've rinsed all of the materials, then I am going to add water to the top of to the measured amount in the volumetric flask. So the 100.00 milliliter mark will have a specific mark on it. And what I want is, if this is the mark, I want the meniscus just to touch that mark. The little bit that's on the shoulders here is taken into account when they make the glassware. So this is a very precise volume, and because we did a precise mass measurement, we also have a very precise amount.